Welcome. Today we are going to open up the topic related to variables. We have been discussing about the patterns. We have discussed something about objects and classes. So we went back and forth related to the patterns and objects in the last couple of videos. And every object will have kind of variable which will be native to that, or maybe something transient to certain operations, and so on and so forth. So before we actually get on to the details about the variables, we have to discuss something important, mathematical concepts. That is what we are going to discuss today. And why we are discussing all that is that you may be a software developer, or you may be a software tester, or you may be a AI algorithm specialist, or maybe AI application developer, or a data scientist. In any of those combinations, for example, you have to deal with quite a lot of variables. And unless you know what the variable is and the behavior of that variable and how it manifests itself with respect to various situations, then it will be very difficult for you to comprehend, do your work. So from that perspective, I have decided to dwell deeply related to three concepts today. And this is not a math class, of course, so you need to understand whatever I am saying from here, and then you have to go back to your sources or maybe books and read that clearly along with computing resources. Then try to correlate what I am saying, then it will be very easy for you to understand and do. Okay, from that background, today what we are going to discuss first is permutations and combinations. Then we will talk about what a mathematical induction is. Then thirdly, on this episode we will discuss on degrees of freedom. So that's the order in which I am going to run through this. Why we discuss that today? A wise man's fear, as mentioned by Patrick Rothfuss. I just read out that it is the questions we can't answer that teach us the most. They teach us how to think. If you give a man an answer, all the gains is a little fact. But give him a question and he will look for his own answers. And exactly that's what we have been doing in this channel, or I have been telling you all along. And if you understand such of these topics, rather, you will be in a position to question whatever was the problem given to you, so that you can find an answer for yourself and move along, so that you can meet your goal from that perspective as well. And maybe professionally also you will be a qualified software engineer or programmer or whatever it is. So from that note, if you see this, what is a permutation? It's basically, in simple English, it is a number of combinations or options available. Okay, why we need to do all that? What is the use of that in computing? Before we get down to that, let's take some simple example. There are some conditions, like when you are going for a function, the number of chairs will be fixed. Like in the front row there will be 10 chairs, and in the second row, third row, fourth row, like that. And you would have classified your guests for that function, like the families or friends, close friends, important friends, VIP friends, casual friends, acquaintances, like that. And within that VIP you would have ranked who comes first, who comes second, third, fourth, like that. So when you have to appropriately have a seating arrangement for these VIPs, for your important family members or elders, you need to apportion that kind of seats to those people. Okay, so let's take from that example, and you are going to write a software program for that. Imagine that way. That's what we are trying to do here. So suppose there are 5 chairs, and in how many ways these 5 people can be accommodated in these 5 chairs. So A, B, C, D, E is the number of people. So A can sit in the first chair, B can sit, or C can also sit, D the same way, E can also sit in the first. So 5 people have gone in any which way in the first chair. So 5 combinations are there. Then you will have in the second seat you will have the remaining 4 people. So B, C, D, E can be accommodated in the second. The same way the third chair, you can have 3 such combinations. Likewise, in the second chair you will have 2 combinations, and finally you don't have a choice, you will have only one person. Whoever is remaining out of that will go. If you really take these kind of things, when somebody picks up the lot, same rule also applies. Okay, so the permutation here is basically 5 into 4 into 3 into 2 into 1, which is 5 factorial in a mathematical parlance, which is equal to 120 combinations. Suppose out of this 10 chair in the example of what we discussed in the marriage function, you are going to accommodate only part of that, say 5 seats for 3 people, 3 seats for 3 people out of that 10. So if you have to take in this example, I'll correlate that. So in the first table you will have 5 persons, and in the second chairs, in the second chair you will have the 4 persons, and in the third chair you will have 3 persons. So you will have 5 into 4 into 3 is 60 combinations you can set. So how will you arrive at 60? This is a simple mathematical formula to arrive at from the list of things. If you have to choose something, then the permutation, which is the number of possible options, or I won't say combination, the possible options are permutation P, capital P in bracket n comma r, where n is the number of people and r is the combinations thereof. So if you really look at the first scenario where all the 5 have to be seated in all the 5 chairs, this is 5 factorial divided by 5 minus 5 factorial. 0 factorial is 1, remember. So that is 120. The same way in the second scenario, this is 5 factorial minus 5 minus 3 factorial, which is 5 factorial divided by 2 factorial. So obviously that is 60. So this is one example of permutation which you have to think about it. There is another example I am going to take. You may be playing with the color codes, right? You have RGB color, right? What is the color for this? What is the color for this? What is the color for this? Everything has got an RGB color. The same way you have also, let's take a simple game with 4 or 5 colors. Okay, in this example there are 6 colors. Okay, and you have to form 4 colors to make a code, right? So this is blue and red and yellow and followed by green. So that is one color combination, that's color code. Whereas the other color code could be the green, red, yellow and blue, which is the second. Though you have got similar colors, but they are not the same. Okay, so they are 2 different codes, or code meaning here is like your employee code. That way this is a code. Okay, this is a second combination. So then how will you make these choices from 4 out of 6, right? So this is, you apply the same formula, you will have 6 combinations into 5 combinations into 4 combinations into 3 combinations. So in that way you will identify the number of permutations possible with this kind of arrangement. One more example with respect to combination, what a combination is. So from these permutations, if you have to make, you have to choose something, okay, that's where the difference is. Okay, if you have to choose something, then you are going to get some combinations out of that. Let's talk about that from this sample. So again there are 6 and we have to select 3, so 6 into 5 into 4, and which means this is 120 combinations. 6 into 5 into 4 is 120 combinations. So these 120 combinations can appear like this, like ABC or BC, ACB, BAC or BCA, CAB or CBA. The same way you can use with F. Same way we can do, like we can go on to make these 120 combinations. But if you really look at, you have to make a combination in which, out of this 120, you have to make a combination in which only ABC are present, which means that there are only 6 combinations. For example, from this 120, you have to choose only ABC, ACB, BAC, BCA, CAB and CBA. Only these 6 will have ABC. Others will have maybe ABF or BCD in any combination. Okay, but only these 6 combinations are possible. So how will you find out programmatically, for that matter, how will you get these 6 combinations from the list of A, B, C, D, E, F? Okay. So the simple logic for this is combination. So it is called 6C3 because you need 3 letters in a particular combination and it has to be from this 120 combination made out of these 6 codes. So this is 120 divided by the number of ways to arrange these 3 letters. Okay, so which is 120 by 6. So if it is only ABC, it is 6. The same way, if it is FCB, there is a second one. Like that, you can go on build 20 such combinations. So if you understand this mathematical formula and if you are able to translate to any program, then you will be in a position to identify this. Okay, you have to remember one important thing. These kind of permutation combinations is perfectly fine, but you have to remember that if you are going to find, for example, this how many ways this can be done. So these are 20 combinations. Okay, you slightly make the question tougher. Like out of these 20 combinations, suppose 18 were identified or 18 were identified and you have to find out the possible remaining 2 such combinations. That means on one hand the constraint has been fixed that this 19 is available to you or 18 is available to you, find the remaining one. It could be the intuitive way of questioning, whereas the plain way of questioning is find the number of combinations. So which is in this case is 20. So you have to remember the kind of programs you are asked to write. For example, it could be even in a entrance test or in a written test on a programming language, or it can be even on your work. So you have to find either this 120, you have to write a code to get this 120, or you have to write a code to remove this 19 combination and find the remaining 20th combination. out of they won't give you what is 20. Okay, so you have to first get that 20. The 19 would have been given to you, and you have to find what is the difference. Difference is not like simple 20 minus 19. You have to find maybe from an array or from a set, then find out what that difference is, and give the answer. Your program should print that answer. Okay, so these are all the ways by which permutation and combinations will work. So very simply, for algorithms, this is one this one important concept for you to understand. Okay. Now with that background on permutation combination, we will be again dealing with all these topics. Whenever we move forward, we will always retrospectively look at how whatever concepts we have been discussing so far will help you to learn better. So now I'm moving on to the second one, that is mathematical induction. First, you have to be you have to be very careful when to use what. Okay, so this mathematical induction is a useful technique for verifying that any algorithm works correctly. Okay, correctly is how you define the spec or expected output. Okay, particularly for algorithms with very different properties related to natural numbers or integers. So obviously, whenever you are using probably plus plus or plus equal to or equal to plus in increment, you need to remember this mathematical induction, because that's the I'll show you the sample code also, and that's how that's what it is behind. Okay, it may not be suitable for all algorithms or for proving correctness in all scenarios, because there are certain assumptions, and if that algorithm meets that assumption, then mathematical induction will work. It is also not a guarantee that is a bug free, like meaning instead of putting plus equal to, if you put equal to plus, the whole value changes. So you need to be careful, or when to call the recursive function. If you change the position or after something, after this variable or before that line, the whole thing will change. So you need to be extremely careful with that. It is also important to consider the complexity and the assumptions involved in the induction proofs. See, we discussed about assumptions in general as part of the self-improvement series, but you have to also understand that how these assumptions, because you say that 1 plus 1 equal to, you decide that if it is 3 and you are trying to make a proof out of that, it may not work. So whatever is the assumption you are going to make, that should be meaningful, and meaningful from the context of mathematical induction. Okay, therefore we need to complement the induction with other testing and validation tools. Okay, so that is a clue here. We discussed in the very start, you have to use these mathematical induction techniques wherever there is a testing, whether it is a chi-square testing or chi-square testing as some people call, or t-square testing. Okay, and if you are writing test cases, and how many number of test cases you will write, and how many is passed and how many failed, so you put a distribution and take off the outliers or this, and try to take an assessment of how your product or solution has performed before you release to the customer. Then it is important that you have to take a t-distribution to get the confidence level, degrees of freedom, etc., to find out whether the product really qualifies for a release or not. So you have to apply, some people may question or wonder or ridicule where the mathematics is in computing. So from that perspective, you have to always remember that whether you know it or not, all these things have got to play in your programming, and you may not know, or you may not even understand that this was behind your assumptions or your reasoning behind why you release the product or not. So it's quite a useful tool anyway. So this is the code. For example, you have to use a very simple base case. That is the first step in mathematical induction. it has to work under a particular base case, under one scenario, and it has to work in a specific scenario, and it has to work in a specific scenario plus one value. Okay, under three conditions it has to work. So this means that either the three can be on the same dimension or no, or I mean degrees of freedom, or on 3 degrees of freedom. That is based on what you want. This code, for example, you identify the base case and then prove that this algorithm works with the base case, and it works. Then put a tick. But that does not mean that the piece of code is completely right. Then there is an inductive hypothesis, which means that it has to work under a specific scenario, and it should work. And the third one is the induction step. There it has to work on the n plus 1, or usually mathematical induction is represented mathematically as k. Okay, so it has to work in the k plus 1th scenario also. Okay, the point here is that it has to work under these three conditions always. With that, if you see the code here, the sample code, in a base case, if n is equal to 1, programmatically, then return 1. Okay, that's a simple base case. So the program will return 1. So that's a tick, and it works. And in the recursive mode, you will call this the same some data with another value. So it will based on the code, it will add plus. This is the sample code, for example. So for integer, it will take the value, then return this. So this is a very simple case where this program returns. Okay. So in this scenario, if you look at for int, this is the sum. This is the program. This returns void, whereas this is a sorting example. Okay, sorting generally in any interview, sort mechanisms will be asked, and you will be tricked also there. Okay, you have to be careful. So it has to be on a sort. This is a C code, simple C code. So there is an integer which is passed, and there is an integer pointer also. So then you have to sort and put all these things into that particular array and return. So in this case, this is a the integer array which has got a sorting technique. Then like that, see, you will write lot of programs meaning lot of functions or methods which you will use as a maybe a helper function, and you will be calling these functions from somewhere else, and that will return the value. So again, on a positive note, if you say that you give 5 array values and ask the program to sort it out, it will give in the ascending order or descending order. It will give you 1, 2, 3, 4, 5 or 5, 4, 3, 2, 1 based on whatever you say, or and it returns. That's a simple forward looking question or approach. Again, from a analytics perspective, out of that 5, 4 values have been defined or have been given. What would happen to the 5th value? What could be the 5th value? So it can be, the output is predefined, and you have to find the 5th value. It can be in the reverse also. So you have to appropriately use this algorithm for a forward way or to find out a particular value, or if the particular value, for example, is has to be 5. And if you are getting a program, an output like 3 or 4 or 7, for example, then there is a deviation from the expected value to the actual value. So from a testing perspective, you need to think. Maybe from a AI perspective, what will happen is that if it is a training model, they will use this value to train the other data which is coming up subsequently using this iteration. So that's how the training model works. But let's not go into that for now. We'll maybe on the AI side. So from the mathematical induction, it has to work on three conditions, like the base case, the hypothesis case, and actually the induction step, which is k plus 1th step. And if your program works for all the three conditions, then is a tick. Okay, from that perspective, we will move on to the third topic for the day, which is degrees of freedom. If you look at this degrees of freedom, see, very simple. There are two variables, right? Whenever say freedom means something over the other, so there are at least two parties involved. Okay, or if there is one party, then the degrees of freedom is 0. Okay, so let's take an example of a simple equation: y is equal to mx plus c, which is x-axis, and y-axis if you put and draw. That's what I'm showing it here. So if you look at simple y is equal to mx plus c, you can draw any number of graphs as you see on the top left of this. If you really look at from the top right, then what will happen is that if you decide to put the value of c as 2, which is a constant from x-axis to y-axis, that's the value 2. If you point that, every line has to go through, and you can still make any number of lines. But in the first scenario, y is equal to mx plus c, there are two variables which is going to define the output of the function y, which means that m is the slope or the gradient and c is the constant. So these two degrees of freedom is going to make the difference to y values. X comma y will always depend on 2 degrees of freedom. Whereas in this scenario in the top right, where y is equal to mx plus 2, because 2 is fixed, y and m is the only degrees of freedom, then the number of degrees of freedom that function has got is 1. Now to the left bottom, if you look at, y is equal to 5x plus c, which means that at every level you will have a parallel lines cutting the x-axis at 5x at the constant c. Okay, maybe this way also. Okay, so here the degrees of freedom is still 1, which is because of c, because m is defined as 5, right? 5x. So y is equal to 5x plus c has got 1 degrees of freedom. And suppose you have y equal to 5x plus 2, the number of degrees of freedom is 0, because any which value of x, it is always going to be one line you will get. So there is no degrees of freedom. So it's always it will be only this particular slope. Why we are discussing is that these variables in the context of an equation. In this equation, y is equal to mx plus c, that is the equation we are talking about. In the context of this equation, there are two possible degrees of freedom, and you can have any number of lines. So if you are drawing a graph, we will discuss about graph theory in detail down the line, but for now y is equal to mx plus c is a simple graph, line standard x comma y graph, line graph. If you take that, when you are asked to write a program to reflect this, then what will happen is that you have to remember how many such lines you can draw. okay, in any combinations. So you can find the pattern. We discussed about the patterns, right? So when the top left is given, by looking at it, you can say it is a two-dimensional or 2 degrees of freedom graph. On the top right, by looking at everything, goes through the point. In your back of the mind, you will know that all the graphs go through the same point, which means there is only 1 degrees of freedom, and in the bottom also it is 1 degrees of freedom, but the slope is fixed, whereas the constant varies still. And in the third and the fourth case, there is no degrees of freedom. So you can easily find this pattern. Let's move on to the another example on degrees of freedom. Okay, you are given 3 numbers 1, 2, 3, and you have to ensure that the average is 2. Then what are the ways by which you can get it? You can get it as 1, 2, 3 as 3 numbers, or all 3 can be 2, 2, 2. Okay, assuming that the value of x is greater than 0 and less than infinity. Okay, and let's say only these 2 possible combinations are available for you to or these 2 data sets, or the sets available to do that. Assume you are putting a value 1, 1. Then what could be the third value? Third value has to be only 4, because the average has to be 2. So in this example I am talking the reverse first. Okay, I am not asking you what is the average out of any 3 sets. Then in that case, x, x1, x2, x3, all the 3 are variable, and each one has got 1 degrees of freedom, and so there are 3 degrees of freedom for a 3 data array. Okay, then the average is always 2. Okay, but in this example the average is fixed first. So if you are given a value 1, 1, then the third value has to be only 4. Suppose you are given a value like 2, 2, the third value has to be only 2. Okay. So depending upon what is given to you and what is expected from the program, you have to appropriately decide the or get to know about the degrees of freedom. Okay, and work out your your code in such a way that whether you are getting the value, the third array value is 4. If the value is 4, then the average is 2. If the value is something else, then that fails. That particular program fails. If you are a test developer, that's another role. I don't know how many of you know that. There is a test developer who has to run whether this program will give you the desired output. Then the test developer will will set the value as 2 as an average of these 3 variable, and decide 3 test cases by providing x1, 1, 4 whether he is getting 1, and 1, x2, 4 whether he is getting again 1, or 1, 1, x3 which is where he is getting value as 4. So he will write 3 test cases to get this value. So the number of test cases here in this scenario is 3. Let's say the set is 5 and average is 3, and every value has to be greater than 0. Obviously it will fail. So the test developer has to have that kind of acumen. We discussed about the combination, right? In the 5 value and you have to get the value 3, that will never happen. So that combination is not at all possible. So then there is a problem with your application or the way you think about the code. or something else is wrong. So you have to write definitely a different program or a test case to understand. So here the use of this in a different sense is that in a single page you have to test. For example, you will have such a number of combinations of or degrees of freedom based test cases you may have to write, and in each of these scenarios you can be maybe to start with you will do all the unit testing and whatever the other types of testing, and you have to run the entire application once. Obviously you will run it, but if you have to do it daily, you would like to take a chance saying that I have not touched some part of the program, so I'll run only a part of the my master list of test cases. So in that scenario, what will happen is that there is a population sample. Say there are 10,000 test cases, and you have a sample size of say maybe 100 test cases you want to run and see to confirm whether things work. So for any of this population and sample variance, basically this is with respect to variance. If the sample output is has got a very high degree or less degree of variance, then everything is conforming to your expected output. So which means that the population is also expected to be normal and it should work. But on the other hand, if the sample fails, so you have to redo the whole testing from for all the 10,000 cases. So like that, based on how you organize your test cases, these things will work. So that is the degrees of freedom we have been discussing about. So just to recap, we discussed about the first is what did we discuss? Permutation combination. The second, of course, the mathematical induction, and third is the degrees of freedom. And just to set the context, all these things related to data. Data, it can be obvious data like what is your age, name, something. Those things are very obvious, or business or transaction data. Certain things can be perceived data, like I have taken the mean, right? So is this a calculated data or perceived data, or it can be imaginary data, any of those things where it is arrived at. Okay, maybe you apply some logic and arrived at that value and stored it. Maybe certain things are not transient in nature, like you within the program you may declare a variable and store these things, and use this variable down the line in the program, or maybe use it in the in another function of this same class, or maybe it may be a global variable in the application context, or it may be a variable of the class or the page which needs to be available throughout, and so on and so forth. Or certain things maybe in the context of what you call a page rendering, whether such variables will be used to render a page or not, or render a control or not. And accordingly you can write the test cases, accordingly you can write the algorithms or test the algorithms, or in a reverse way you can find out whether what is rendered is correct, or if not correct, what could have been the value, and if there is a difference, then you can use AI to model it in such a way to train to minimize in such a way that your AI logic also works. So there are so many importance related to these data, and that is why we discussed this today. And in the next video or the next set of videos, we will be slightly go back and forth related to class, objects, and variables, because the whole life revolves around that in computing. Okay, so with that note, thank you for watching. This is Gokul. See you in the next video. Hope you find this useful, and give me your comments there. In case if you wish to call me or contact me, please send a message in the comment. I'll try to get in touch with you. Thank you very much. Have a nice day. Cheers.